Alright, we're heading down the home stretch. We have an output jack. Make sure that you install it, not that way, with the wire inserts on the outside of the board. I've had to undo these because I put them in backwards. What I use for one of these is a reverse set of tweezers. See, there we go. And I'll just solder one terminal. The reason I only solder one of the two terminals is I want to make sure that it's square or flush against the board. And it appears that it is. So I can finish off that. Now the input terminal is a 3-screw device, except the center terminal is unused. I'm not sure exactly why they did that, but there we go again. It's not required that you have a center tap transformer. We have 3 polarized sockets. Those little teeth, you see them on the board? Whatever they are. Little inserts. That corresponds to this. And you can see that if I install it here, it sits nicely in the box. If I install it the other way, it doesn't fit so nicely. So we can just assume that this was designed to go this way. Again, I'll use my little tweezer here. Now it's a little harder with this one because the tweezer actually obscures one of the solder terminals. We'll solder one. Now you see it's a little twisted, and so what I do is to keep from getting burnt, I'll put a rag on here and I'll try to move it a little bit. Now, I would have done the same thing if it was not flush against the board. But don't use your finger. You'll end up heating it up and burning it, your thumb. Just using the best fit method, it looks as if these little sharp teeth, in fact, I think they'll mount this way, with the teeth facing inward. So what's left? All the big capacitors left. Need I say it's polarized, etc., etc., long lead positive. It can set tight against the board. It's an HDF brand. It looks like the only holes left are the 3 identical ICs and the this fellow. Now I intend to mount him remotely. Unlike most Chinese kits, this one included no sockets. The sockets are certainly optional, but it's not like this is a high frequency operation or anything like that. So I'm going to put sockets. The solder mask has a little divot on one end. The socket has a little divot on one end. So make the socket face the right way. So we'll bend over a little bit, diagonally opposite pins. Put all three in that way. When soldering these IC sockets, solder one pin, one of the end pins, doesn't matter which one. Then actually take your thermal barrier, put it on top of one of the sockets, press gently and melt the socket, melt the terminal. Okay, and I felt it snap against the board. Now push it gently, because if you push too hard, you'll dislodge the pin through the socket. In fact, it's best if you don't apply pressure at all until the joint is melted. Now we'll just go ahead and solder all 3 times 8 pins. What I want to do now is power the board up without any of the op amps and without this big fellow. To do that, I'll use one of these 24 volt 1 amp transformers. Alright, see what I've done. And I'm going to plug it in and we'll see what happens. Doesn't look like anything happened. So we get a double-ended ribbon cable. I'm going to fold it over and cut it in half. So what I've got is this transistor hooked to the circuit board, and I've got it clamped with a hemostat to this heatsink. Now, because I'm not using an insulating washer, this and this hemostat are probably, well, either input or output voltage. I haven't checked which. I've hooked up two 10K 10 turn pots. The only things left in the bag are two 270 degree turn potentiometers and the little red LED. And I've got to insert these chips. Now, first thing to do is to make sure that the pins are actually straight. Here's one that's bent off to the side. Now, one end of these are identified with, in this case, a little dot. Sometimes there'll be a divot that matches the divot on both the socket and the circuit board. Bend these leads inward this way. And just seat the device. Obviously there's no current being drawn, but the pot seems to be rotating the correct way. Because these two wires were independently cut from one piece. Notice that this one, when I straighten it all out, is solid on the left and dashed on the right, while this one is just the opposite hand. Okay. Now, these 10 turn potentiometers, and by the way, the date code is 380. So I salvaged these, 40 years ago? They were made 40 years ago. And the center wire is to the wiper. The leftmost wire is to a terminal labeled counterclockwise, and the rightmost wire is to a terminal labeled clockwise. You'll notice the little silk screening says that clockwise, is that this way? And there's a V increasing. The worst that could have happened was I would have hooked these, I would just have to swap these. See, a 10 turn pot typically doesn't have the 3 inline terminals. The winding or the resistance wire spans here to here, and then the wiper is down here, actually labeled SL. Maybe this one's clearer. SL, counterclockwise, clockwise. So this is traveling in this direction when I turn clockwise. So the little thing works. I'm not comfortable, and I never have been, with this design, in that these devices are operated 2 or 3 volts above their absolute maximum ratings. I believe this device is rated for 40 volts maximum. You can see that's 37. But this one is 42 and almost 43. And this one is the same, 42, 43. So these last two devices are above the maximum rating. This is below 40, but pretty close. Well, now that it looks like the little power supply works, I'm going to enclose it in this case. I'm going to try to squeeze 2 of them in this case, but I doubt that I can do that, because I'd have to put 2 boards in, 4 potentiometers, and 2 transformers. The transformers are killing me. Well, yes, I can. I can get 2 boards in this way. Remember, I can't put anything where these screws are, here and here. But allowing enough room for short potentiometers, and keeping the boards up against these, I think I could get the potentiometers in there. Then could I get two transformers in? And so the transformer could sit forward over the board, because remember, I'm not going to put a heat sink or anything in here. So if I bias the transformers down as far as I can get down here and here, I could probably get an IEC connector on the back of the supply here. I'd mount the heatsink external to the case on the back. Offset a little bit so I can get the connector on. Would I do any better to mount the transformers this way? Perhaps I do a lot better that way. I could take this frame off. Normally there's 4 holes in the corner of these transformers, but there's no real need for it. But I think I could squeeze the transformers in. Now we've got some other problems. If I use the displays on the front, they'll need an external power source. I'll take this all upstairs and I'll do an AutoCAD drawing and see if I can fit all of this stuff in the case. How about that? So this will be the end of the first 3 parts. The next time I do a video about this little power supply, it'll be putting it in a case, either one or both in a case. But I don't want to use a case that I've got laying around. I want to put it in a case that's available to you viewers. I recently, in a mail video, showed the opening of this case, the seller's name, and the price of the case. I don't remember. So, you know the routine. Thumbs up, subscribe, comment, and thank you very much.